Good evening.
Good evening, sir.
Okay, so I think let's we start the today's session because we have to already finish around 60 questions like other days. 50 simple questions will be from the this week lecture and 10 sample problems we will be doing and solving that one also. So I think I can share my screen and we can start the today's session. And whoever will be joining, I will be admitting them in between the session. Okay. So the screen is visible to both of you.
Yes, sir.
Okay. Okay. So welcome to the problem solving session of this week 9 and like our previous sessions this week also we will be solving the problems and some sample problems on the NPTEL course on sustainable architecture. And as you all know, this week also I will be taking your this session, and I want to mention that in the subsequent weeks, wait, someone is writing. I wanted to mention it clearly, like in the subsequent week, the lectures more it will be focused on the one of the most I should say one of the most uh, famous or most demanding software design builder in whoever who is working in this area of buildings and sustainable architecture. They before doing the actual constructions they used to do some sort of case study or simulations to understand the actual performance of the buildings. So practical hands-on experience on those software, how to use that one, it will be discussed in the next lecture videos. But we will be also focusing and trying to learn. There will be, you can say, some hands-on session or workshops wherever we will be trying to analyze the various features of the software and mm, get in touch with that, so that whenever you will be doing or some sort of assignment or some sort of future project works, then it will be beneficial for you. So more or less how it has to be installed, these things will be discussed in the next week lectures, that when you will be learning it in the week 10, then you will get to know that. So this week we will be focusing on the content of lecture 41 to 45, and we will be solving some of the simple problems. But before that, starting to that or moving to that, I wanted to add some small discussion on the previous sample paper problem solving and problems session 8, that is. And where if you all are uh, if you all were present, then you must be knowing that we have solved the question number 2, where most of us were facing some sort of I should say doubt in the answers. So for better understanding of the topic and with more detail, I want to discuss those two sample questions whose answers most of you were having some sort of confusion in that. So can we start with those two questions first?
Yes, sir.
So I hope you will be able to relate. I am firstly referring to the question number 2 of the sample problem, where it was discussed. The statement was written, you, and it was asked from you whether it is true or false. That type of question was asked. So I am making correction to the answers for the last time. Some corrections are there, and with this I would like to clear the doubts also. So in that, initially it was written that the conductance is dependent upon the thickness of the material, while conductivity is not. So this statement, most of you were answering false, most of you were answering true. So the final answer to this question is true, because try to understand this thermal conductance, it is not other than the reciprocal of the resistance. And if you are knowing about the resistance, or if you are talking about wall, then it will be the resistance reciprocal. If you are talking about the resistance in heat transfer, then it is L upon Ka. And if we will do the reciprocal of that and we will evaluate the thermal conductance, then we will find Ka by L. So whenever you are evaluating the value of thermal conductance, then you can see it is dependent upon the parameters K conductivity, A area of the surface, and L, because it is Ka by L, where L is the thickness. So it is written that conductance is dependent upon thickness, and it is true. And another thing was written that conductivity is not, because the thermal conductivity is the property of a material itself. It does not vary with the thickness. If you are cutting some section of the material, or say some wire you are taking or something, so it is not varying with the length or with the thickness. Are you getting my point?
Yes, sir.
Yeah, so that statement was true. So whoever were marking false, they were going in the wrong direction, and whoever were marking true, they were going in the right direction. And the final answer to that question is true. Conductance is dependent upon the thickness of the material, and conductivity is not. Is it clear now?
Yes, sir.
Okay. So one last question I will be discussing from the previous session. Then we will be moving to the next session questions, and that was from the sample question 9. So I have corrected these two answers in the final uh, sheet that we have been provided to you, and the PPT that have been uploaded in the drive, so you can see through that also. So another question was that if you could recall, then you must be knowing that specific heat and thermal conductivity are unrelated to each other. So for this, whether this is true or false, the two options were given, that specific heat and thermal conductivity are unrelated to each other. So the final answer to this question would be false. This specific heat, as I was telling last time also, if separately we can relate it with the temperature, like specific heat will vary with respect to temperature, and conductivity is also not constant. Thermal conductivity is also dependent upon the temperature. So what I mean to explain to you last time, that separately this specific heat and thermal conductivity we can relate it with the temperature. But if you want to provide the relationship between both of them, so specific is heat is dependent upon temperature, and thermal conductivity is dependent upon temperature. So if you will increase the temperature, or if you will decrease the temperature, or else you can see the temperature is the link between both of them. So if you try to relate both of them, then in terms of temperature you can replace, if you are having some sort of equation of thermal conductivity in terms of temperature, then that temperature portion you can replace what you can write from the equation of specific heat and temperature you are having. You can replace both of the equation, and then one relationship you can develop between this thermal conductivity and specific heat. Or else in the other sense you can know that specific heat refers to the amount of energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. It measures the material's ability to absorb or store heat. That is the definition of specific heat. And thermal conductivity, it also measures the material's ability to conduct the heat. It describes how well the material can allow the heat to travel through the material. So if you will find, these properties are different properties, it is for sure, but they are connected. How? Because they influence the heat flow, or how heat is managed in a material. Both property, they are just managing the how heat is flowing in a material. For instance, a material with high thermal conductivity, you can relate it to with real time example. If a material is having higher thermal conductivity, will, that means it will transfer the heat quickly, and a material with high specific heat can absorb the heat without much significant rise in the temperature. So both are talking about the heat. So both are related to the temperature, or both are related to the same property or same quantity, that is heat transfer or flow of heat. So indirectly you can say, you can relate both of the terms in terms of each other. So saying whatever the statement was written, specific heat and thermal conductivity are definitely unrelated to each other, this statement is false. Is it clear now?
Yes, sir.
So both the answers, so whoever are having sort of doubt, they can discuss now or they can correct it, that the statement specific heat and thermal conductivity are unrelated to each other. It is false. They are related to each other, although they are different properties we know, but more or less they can be related in terms of temperature or in terms of heat flow, because they both are talking about the same quantity. So I hope this is now clear the doubts of most of the students, and this one you can mark as a final answer if it is asked in the exams also, so you can answer it correctly. Is it fine?
Yes, sir.
Okay, so let's move to the today's questions. Some of the questions, and we will pick 10 questions from each lecture from beginning from the lecture 41. And here is the first question for all of you, and try to finish within the stipulated time period, so that all the 60 questions can be done within 2 hours period of time, 2 minutes for each of the questions. So here is the first question for all of you. So this is from the lecture 41, Indoor Environment Quality Part 1. Try to answer to this question, and how you understand the definition of sick building syndrome. From that you can answer to this question, particular question, question number 1, which will be the most suitable answer for this question. Can anybody tell? Wait, someone wants to join. Let me join him or her.
Option D, sir.
Okay. So everybody try to give your participation and answers in the chat box. Okay, all of you have given also. So I think this definition of sick building syndrome is very clear to all of you, that option D is the right answer for this question. That is a persistent set of symptoms in more than 20% of the occupants with no recognizable cause. Or if you will go in much detail, then you will find this sick building syndrome refers to a persistent occurrence of illness symptoms. That symptoms can be headache, fatigue, or eye irritation, and that is accounted in more than 20% of the building's occupant with no clear identification of the cause. In such cases, you will call it as a sick building syndrome. Is it clear? Can we move to the next question?
Yes, sir.
Okay, so here is the second question. Let me admit. So here is the second question. So this question is also asked. Screen is visible.
Yes, sir.
Okay, fine. So it is visible to all of you.
It is.
Yeah. So all of you try to give your answers in the chat box. Then we will be moving to the next question. What is the maximum acceptable? What is this? Carbon dioxide level concentration in the indoor to avoid a sick building syndrome. Beyond that particular ballpark number, the environment conditions or indoor air quality will not be considered to be suitable for the occupants. So what is that number? How much is under in the range of? manageable range, you can say, or comfort level. So what's the answer for this question? Question number 2. Anybody wants to answer?
1000.
Yeah. So it is 1000 ppm. The maximum allowable CO2 concentration in the indoor is 1000 ppm. If it is not maintained, that means you are going towards the sick building syndromes, SBS, what is written, or you are not, you will feel discomfort, or you will feel headache, something uh, sick feeling you will be having. So the permissible limit is 1000 ppm. So it is not defined that if you are maintaining more than like 1100 ppm, so if you are not feeling sick, or you are not having some sort of these issues, then don't think that it is we can also go for 1100 ppm and all. If you are not feeling it instantaneously, then it may cause some long term effects. So that's why this 1000 ppm is the ballpark, or that is advisable by most of the uh, indoor air quality certification agencies also, that it has to be maintained. Below than this is better, above than this is hazardous. Is it fine?
Yes.
So here is the third question for all of you. Try to answer to this, the third question of the day. What health issues are associated with the exposure of nitrogen dioxide in indoor environments? So different gases and their hazardous effects were explained to you. So based on that, you can answer to this question. Question number 3. Which sort of problems will arise if you are getting exposure to the nitrogen dioxide continuously in your indoor environment? So anybody can recall what harmful effect or health issues nitrogen dioxide will cause out of the four options? A, B, C, D. Lung cancer, irritation to skin, eyes, and throat, kidney failure, and neurological disorder. Which will be the most suitable answer? Nobody of you are able to answer to this question.
Option
So option A is not the right answer. You can parallelly open to the slides of lecture this 41. Then you can see parallelly. You are having the slides with you.
Yes, sir.
Yeah. So whenever you are having some sort of doubt in some of the questions, then you can go through, and this will be also kind of revision for you. So you can go through the slides again, and you can see what will be the health issue caused due to the exposure of nitrogen dioxide. And I want all of you to give the right answer for this question. Then we will move into the next question. You can open the slides and answer to this question. Question number 3. If anybody is confident with the answer, then he or she can speak. Out of the four options, which you think to be most suitable one?
so.
B.
B. You are absolutely right. Option B is the right answer for this one. The health issues associated with the exposure of nitrogen dioxide in the indoor environments are irritation to skin, eyes, and throat, as well as sometimes coughing is also observed. And it is also said that it is important to maintain its concentration below 0.05 ppm. Like CO2, you can go up to 1000 ppm. But in case of nitrogen dioxide, you have to maintain its concentration below 0.05 ppm. Is it fine? Can we move to the next question?
Yes, sir.
Okay. So here is the fourth question. So from the same slide, and where the health issues with associated with different pollutants were mentioned, you can answer to this question also. So out of the four options, which indoor pollutant does not primarily affect the lung or is the primary cause of lung cancer? So three of them will be associated that will affect to the lungs or lung cancer. But one option out of the four options is not primarily the cause of lung cancer. So out of the four options, try to choose the correct answer. Whether it is radon, asbestos, or formaldehyde, or sulfur dioxide. Let me see who is giving the correct answer today and who has revised the things correctly. Okay, Palvi Pathak is on the right way, I think. She has only answered option D.
Please
So,
show the question again.
yeah, sure. So you can open to the slides of lecture 41 and try to answer from that. I don't think this is a difficult question. Is it difficult? So for you people, let me help you with the slides. If you are not having it, here you can easily see. If you will go to the slides of lecture 41, then you will find the answer to the previous two questions from where it was picked up, and you can open the slides for any sort of doubt. So here is the lecture 41. All of you can see the screen.
Yes.
Yes.
So from here you can see the slides. Here is the slides. You can download it also, or you can see it directly. So in these different pollutant were mentioned here. You can see asbestos is causing lung cancer, isn't it? Radon is also causing lung cancer. So if you will choose out of the four options, what were the four options given to you? This asbestos, radon, they are the primary cause of lung cancer, and this sulfur dioxide and formaldehyde is only left. So you can see the sulfur dioxide. This is also causing lungs disorder or affecting your lungs, but this formaldehyde, it is only causing irritation to your eyes. I think this is now clear. Everybody can see.
Sir.
Yeah. So only 18 slides were given to you in the lecture 41, and I hope you should go through these slides in detail. And if you are not able to recall, then you should revise again and again. So let's move to the fifth question. And the correct answer, I hope now it is clear. For this question, the correct answer is formaldehyde. So let's move to the fifth question. Here is the fifth question. What strategy is recommended to manage carbon dioxide levels in the indoor environments? Out of the four options, how you can manage the carbon dioxide levels in your indoor environments?
B.
B. So you easily you can answer it that option B is the right answer for this question number 5. Whenever you will be planting more indoor plants that will absorb the carbon dioxide and release the oxygen and maintaining or manage the CO2 levels effectively inside your building levels. So is it clear?
Yes, sir.
Okay, so here's 6 question for all of you. Try to answer to this question also correctly. From the same table, you can see which of the flowing material is a method, which of the flowing is a method to manage the particulate matter in indoor air. Out of the 4 options, try to choose the most appropriate one. Whether you will be using materials with high VOC emissions, or allowing the occupants to control indoor temperature, or ensuring adequate ventilation, or increasing the indoor humidity. Which will be the right answer?
Option C.
Okay. So option C is the right answer, and I hope all of you have. Yeah, I can see all of you have given the right answer. Option C only. So with the help of this adequate ventilation, you can remove the particulate matter from indoor air and reducing or introduce the clean air and exhaust contaminated air you can eliminate. So let's move to the next question, 7th. This is true false questions, and try this will be very straightforward questions. Try to answer to this question also like you have given answers to the previous questions. Outdoor air quality has no impact on indoor air quality. Is it true or is it false? B. Okay. So all of you are in giving the right answer. So can anybody explain me how this is false? How far you understand?
The outdoor air quality which is entering a building.
Yeah. So outdoor air, if the outdoor air quality is bad, so it will directly affect the indoor air quality since the contaminated outdoor air can enter inside the buildings, specifically if it is not properly filtered, then it can enter and for ventilation purpose or through infiltration, it can enter inside the buildings and it can affect the indoor air quality. That's why the answer is false, and all of you are going in the right direction. So here is question number 8 for all of you. So what is the maximum allowable concentration of formaldehyde? From the same table you can see the permissible limit of each concentration was also written. So what is the allowable concentration of formaldehyde in indoor air for continuous exposure as per SRA standards? So what will be the right answer out of the 4 options? 120 micrograms per cubic meter, or it is 5 micrograms per cubic meter, or 150 micrograms per cubic meter, or it is 1000 micrograms per cubic meter. Anybody can recall, or they can you can revise also and you can move to the slides. Let me see how many of you have answered to this question, particular question, how many of you were able to understand. So I have received 2 answers, Payal and Pallavi. So both of them are saying it is 120 micrograms per cubic meter. What about else? They are still thinking or they are going towards the slides? They are revising the slides.
In these slides, sir, I have seen it is
How much?
120.
Yeah. So both the persons have given the right answer. It is 120 micrograms per cubic meter. The SI standard for maximum continuous exposure of formaldehyde is 120 micrograms per cubic meter of air. Fine.
Yes,
Yes.
sir.
So let's move to the next question, ninth question, and let's see how many of you can recall what is the maximum acceptable concentration of carbon monoxide. So for this, we used to put some sort of sensors in our homes or lecture hall theaters, and we measure how energy efficient or it is good for the health of the human beings or occupants who are staying there, how well it is constructed. Like one of the lecture hall in our college, it is not that much good ventilated. So if it is not good, that much good ventilated, and lot of people, like around 50 to 60 people, will be sitting there for 1 hour or 2 hour lectures, and they will be exhausting the carbon dioxide, then the concentration of this will uh, keep on increasing with not proper construction or proper design. So those monitoring also you can perform whether this classroom is suitable for human health or not. That kind of study is also done. So that's why you should be knowing the limits. What is the maximum acceptable concentration of different pollutants? Then only you can match the with the standards, and you can see whether this is good for health or it is affecting our health, or are we really ill, or it is sick building syndrome. Am I clear? So with this, you can answer to this question, question number 9.
C, sir.
How much it is?
9 ppm.
9.
Okay, so it is 9 ppm only for this particular carbon monoxide pollutant. As per this EPA standard for maximum carbon monoxide concentration in the indoor environment is referred to 9 parts per million, and higher level if it is maintaining, then what will be the effect it can cause? That also you can answer, that it will lead to the headache, shortness of breath, or even sudden death sometimes it can cause. That's why maintaining proper concentration of carbon monoxide inside your indoor environment is very very necessary. Let's move to the last question of this lecture 41. Here is the last question for all of you. Which indoor pollutant has similar health effects to carbon monoxide but reduced at reduced intensity? It is more or less having similar health effects that I have discussed earlier questions, like headache, shortness of breath. These similar effects you will be getting, but you will be experiencing it, or it is less effective than carbon monoxide. It is in reduced intensity. So which of the following pollutant it can cause similar health effects? Okay, so I think Krisha and Elena is absolutely correct, because they are mentioning C. So from the similarity, or from the this naming also, you can see this carbon dioxide and carbon monoxide both are more or less similar, and that will be causing similar health effects only. But this carbon monoxide, it is more effective, or it is more dangerous, you can say. And this carbon dioxide has health effects similar to the carbon monoxide, but at reduced intensity. It is affecting the health when concentration are above the acceptable limits. So similar health effects like carbon monoxide, carbon dioxide can produce. Is it clear?
Yes, sir.
Okay. So with this, we will like to end to the lecture 41 sample questions. Now we will be proceeding to the lecture 42 indoor environment quality part 2 sample questions. And for that, you can open to the lecture slides that have been given to you in the lecture 42, so that if some sort of doubt is there, so you can revise the things and you can open the slides parallelly. So here is the first question from those slides, or from those concepts, that you can answer directly also if you have read the lectures correctly. Which standard is commonly referred to or for acceptable indoor quality in mechanically ventilated buildings. To which standard you refer for mechanically ventilated buildings? Out of the four options, ISO 9001, SRA 62.1, D4, IGBC green new buildings.
Sir, can you please show the previous question?
Previous question, which question? Question number
Uh, 10.
10. Okay. So here is question number 10.
Thank you, sir.
Okay. So try to give answer to this question number 1 of lecture 42. Let me see if you, all of you have answered it correctly or not. Okay. So I think this SRA standard 62.1, this well explained to all of you, and all of you are in the right direction only. So this SRA 62.1, this is the correct answer for this question, and this standard is frequently referenced. You can see it in the research papers or in the lecture slides or through Google also. Whenever you will be talking about the mechanically ventilated buildings, then it is designed and it is rated based on this SRA 62.1 standards. Fine. Let's move to the second question, and I hope similar to the previous question, this question also most of you will be answering it correctly. Here is the second question for all of you. The outdoor air flow rate in naturally ventilated building is determined solely by floor area of the building. Is it true or false? Let me see. This question also I hope is clear to all of you, and you will be answering it correctly. False, false, false. Fine. So I hope this answer is clear. The correct answer is false only, and all of you have given the correct answer. The outer air flow is determined by two factors, and it is the statement is saying it is only determined based on the floor area of the building. That's why it is incorrect. Can anybody tell me what other thing we consider while determining the air flow rate apart from floor area?
So fenestration, then wall.
opening size.
No, if you can refer, you can open to the slide, slide number 6 or 7. Then you can find whenever this air flow rate was calculated, then two things were most dominating or most prominent. First one was floor area, and second one was the populant density or occupant number of occupants within the space. So both the factors will be important while calculating. If you are having, you can easily relate it also. If you are having one person in the room only, so the flow rate will be according to him. But if you are having lot of people inside the room, so the you have to maintain particular flow rate so that no one of them should feel uncomfortable, because there will be some sort of metabolic rate, some sort of CO2 concentration higher in the in this room. So this how much should be the ventilation required? That will be, or how much is the air flow rate required? That will be dependent upon the floor area as well as the number of occupant or population density. Is it clear?
Yes, sir.
Yeah,
Yes, sir.
that's why this statement is false. So let's move to the third question. Here is the third question. In a naturally ventilated building, what percentage of the net occupied floor area should be openable? At least. It is not like you can close all the building envelope. You have to ventilate some of the area naturally. So what percentage of a net occupied floor area you should make openable? 1%, 2%, 4%, and 10%. Let me see how much percent of you have answered it correctly. C, 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 C. Okay. So this is also very straightforward question, and all of you have given it correctly. At least 4% of the net occupied for the area should be openable area. Fine. Let's move to the fourth question. Here is the fourth question. Smoking rooms should operate at a negative pressure to prevent smoke from escaping into non-smoking areas. This is true or false? I hope this answer is also this answer also you can give correctly. Negative pressure is maintained or positive pressure is maintained. So this is true or false? Two persons are saying true. What about others? So Payal and Elena, they are very actively participating in the session and they have gone through the lectures also. They are giving to the answer to the all the questions first time. What about others? Let me see, because this session is for all of you to revise, and if you are taking some sort of time, then it is fine. We can wait. But I want all of you to answer. This is true or false?
It's true.
Yeah. So we have to maintain
True,
some
it
sort
is
of
true.
negative pressure, and that negative pressure, it will be helping you to ensure that the smoke does not escape and mix the air in the non-smoking areas. Thereby, it will be protecting the indoor air quality for non-smokers. Fine. So let's move to the next question. Question number 5. Here is question number 5. What is the recommended minimum distance from building entries and operable windows where smoking should be prohibited? So what is recommended minimum distance that you have to maintain from a smoking zone and the operable windows or building entries? 10 feet is enough, or 15 feet, or 5 feet, or 25 feet? I am talking about the minimum distance. Maximum it can go to anything. I hope this was also discussed while you will be designing the exhaust or buildings, separate zones with kitchen, bathroom, smoking zone, or whatever. So how much distance or how you should maintain the quality as well. Let me see how many of you have answered it correctly. Then I will be discussing about the answer if you are going in the wrong direction. Okay. So all of you are saying option D. So all of you are absolutely right. Option D is the right answer for this question. To prevent the infiltration of tobacco smoke inside the buildings, the smoking should be prohibited within 25 feet of the building entries, or it can be outdoor air intakes or operable windows. Fine. Very good. Let's move to the sixth question and see how many of you can answer to this question also. Here is question number 6. What should be done to the HVAC system during the construction phase to maintain indoor air quality? Yeah, when your building is not 100% ready, it is in the construction phase. So maybe you are constructing the beams or columns or walls. So what construction measure or what uh, should be done to maintain the HVAC system? Whether you will be installing permanent systems immediately, or you will be using temporary HVAC systems if it is possible, or you will be avoid installing the filtration medium, and at that time the air quality is very very bad. When you will be doing mixing, you will be fixing it, drilling it, the quality becomes very bad. So you will avoid it, or the last option, you will increase the indoor temperature. Which will be the most suitable strategy to maintain the indoor air quality during the construction phase? Let's see how many of you are able to answer to this question correctly. Okay, So all of you have answered to this particular question correctly. We will be relying or we will be using the temporary HVAC systems in that regard, because why not permanently? Because the permanently option A, what it tells, that permanently installed HVAC systems should be avoided during the construction, and temporary systems should be used. If you are using the permanent systems, then you have to use proper filtration media during the installation. The most recommended one is the use of temporary HVAC systems, and if you are going for the permanently, then it is going to be getting affected by the lots of pollutant that is going to be generated during the construction phase. Then it can block your pipelines or filters. So you have to, if you are going for the permanent, then it is not the recommended option. Otherwise, you will face some sort of this poor air quality, indoor air quality. That's why option B is the suitable one, and all of you have answered it correctly also. So let's not discuss it further and move to the next question so that we can finish it on time. Here is the seventh question: which of the following pollutant is commonly associated with the poor indoor quality? Commonly, we are talking about which you will find commonly associated, or which is dangerous. You can say oxygen. It is definitely not good. Oxygen is good for the indoor air quality. So which is the most commonly associated everywhere? Let's see how many of you can answer it correctly. Yeah. So Tarun, Palvi, Payal, all of you, every time they are only giving the answer and they are giving it correctly, means they've understood it very well about the week 9 lecture that was purely based on the indoor air quality, indoor environment quality, you can say. So they've understood it very well, and the answer is correct. They've answered it correctly. That CO2 is the right answer. Monitoring the CO2 level is essential in accessing and maintaining the indoor air quality. And if the CO2 level is higher, then it is often reflect the inadequate ventilation, which can lead to the buildup of another harmful pollutants that can cause some sort of critical health issues. That's why we prefer to lower the concentration of this one. So let's move to the next question. That is question number 8. Here is question number 8. Try to answer to this question also. We will be seeing how many of you are able to fix it. All of you try to give your answers. Okay, fine. I have received 3 of answers till now.
The question.
Yeah. So here is the question. The flush out of the building post construction is often skipped through or due to the pressure to complete the project on time, despite its importance for occupant health. Okay. So all of you have answered it correctly, and the statement is itself clear. It is true is the right answer for this question. Let's move to the next question. Question number 9. What is the principle of
Excuse me, sir.
yeah?
The eighth question, I'm having I'm confused because the question states that of a building post construction. So that is, how can post construction be again pressurized for a completion of project on time?
It is not talking about this class out. I'm. It is just asking about despite its importance for occupant health. If you are trying to flush out the building post construction, then you will have to choose the options where you want to skip it, or you want to do it. These building flush outs, these are very very crucial for removing the contaminants from the definition of this one also you can know. So if you are skipping it in practice due to the project time constraints, are you getting it?
Okay, sir.
What I mean to say, some these flush out, it has to be done in the high pressurized systems. So if you are having this completion constraint, so this flush outs is often skipped. Fine.
Yes, sir.
Okay, so here is the ninth question.
Sir, can the flush out, excuse me, sir,
Yeah.
can this flush out be done after occupancy, partial occupancy or
No, no, no,
something?
this has to be done just post construction.
Post construction before occupancy?
Yeah, so that all has to be done, it has to be done in some sort of pressurized, through pressurized system.
In
Fine.
the slide, it was there are two options. One is partial doing in phases,
Hmm.
another is doing it one time.
Hmm.
So if we do it in phases, we can obviously have it partially occupied
Yeah.
one by one.
Yeah, so complete flush out, you mean to say that the complete flush out you can avoid, but you can do it in the phases. Am I right?
In phases, then we won't be
Yeah.
skipping
So yeah.
that
So with
pressure.
this, yeah, yeah, I got it. So the complete flush out you can, if you want to complete the project on time, or within the time frame, then you can not rely on the complete flush out only, as well explained or stated by one of you also. So you can do it in the phases. So you will not be waiting for others. If one of the system or one of the this zone is completed, then you can do the flushing out of those zone frequently or timely. Fine.
So the answer would be true only, sir.
Yeah,
Or
that will be helping in the time saving. It mean to say like that. Fine.
yes, sir.
Okay. So try to answer to this question. Question number 9. Okay. So this 9 is fine. So these all the three options, whatever is mentioned, these are all the principles of mechanical ventilation, whether it is cooling outdoor air or outside to indoor spaces, and this exhaust stale air and control the temperature and humidity inside. So all of the above will be the right answer for this question. Let's move to the last question of this lecture 42. Here is the last question, and this also you can answer it easily. That is the asking, what do you understand by the indoor air quality? Yeah, fine. So the it is well defined as a condition of inside building as it relates to the health and comfort of the building occupants. So all of you are giving the right answer. So with this, let's end the sample questions of lecture 42, and let's move to the lecture 43, indoor environment quality part 3, some of the sample program questions. And here is the first question. So this VOC term you might have heard frequently. So what does it stands for in context of indoor air quality? Okay, so we have known it also. The correct answer is option A, that is volatile organic compounds, that is mainly referred as in short VOC, pollutants. Fine. Let's move to the second question. Which organization is commonly referred for VOC limits in the green building rating systems? Out of the four, which standard or which organization they rate the, or they provide some sort of recommendation or limits to the levels of VOC, volatile organic compounds? So, so here I am getting mix of answers now. I think B, A, C, everything I have got. So read through the questions again and give your final answers in the chat box. Then I will be discussing on that. Yeah, now you people are either you have
Yes,
referred to
sir.
the slides. Now you are answering it correctly, all of you. Option B. Option B, ICC Evaluation Service. ICCES, you can say. This is the right answer for this question, and it is one of the organization that publish guidelines or values for the cutoff limits of the VOC for different materials, commonly referred to by several green building rating programs. Fine. So let's move to the third question. Which type of building material are associated with high VOC content? Whether these architectural paints or clear wood finishes or coatings, out of them, or last option, all of the above, which of the material are associated with high VOC content? So name examples of these and names of various VOC materials were discussed in the fifth slide, I guess. So you can refer to those slides also, and you can tick mark out of the four options. D, D, A. So option D is the right answer for this one, and it was discussed in the lecture slides that the all the materials whichever is mentioned, whether it is architectural paints or clear wood or finishes or floor coatings, all are associated with high VOC emissions. So that's why whenever you will be selecting it, you have to select it carefully based on the VOC emissions of different building components. So option D is the right answer for these questions. Fine.
Yes, sir.
Okay. So here is question number 4. So this question, I think this is also given in your assignment questions of week 9. So if you have completed the assignment, then you would be able to answer to this question, which is similar to that. What is the recommended minimum exhaust rate for spaces like photograph rooms to control the hazardous pollutants? So carefully see the units. It is LPM, and also it is in CFM. So whether it is 0.5 option A or B, C, D, all of you give your answers in the chat box. D, A. Two persons are saying D, two are saying A. We will be discussing the final answer. Let others also answer and understand the questions again. So whether it is 0.5 cubic feet per minute, option per square foot, option A, and option D 1 liter per minute per square foot. Only two answers I am getting, and most of you are saying A now. So A is the right answer, and whoever is saying D, I want to clear them that the exhaust rate should be at least 0.5 cubic feet per minute per square foot in spaces like photocopier rooms to control the hazardous chemical pollutants. This was the example of this photocopier room was discussed, and how it is harmful, or it is liberating lots of pollutants, that was also discussed. So that's why the example of this photocopier room was picked up for this particular question. If you understood those case study or examples, then you can answer to these questions. So 0.5 is the right answer, option A is the right answer. Is it clear?
Yes.
Okay. So here's question number 5. So answer to this question also, and then we will be moving to the next question. Let me see how many of you have answered it correctly. Okay. So now this, for this question I'm not getting mix of answers finally. All of you are going in the right direction, and this statement is absolutely correct. That is, the VOC react with the sunlight and nitrogen dioxide or nitrogen oxides to form ground level zone, which has negative effects on human health, agriculture, and ecosystem. This statement is absolutely correct. Can we move to the next question?
Yes, sir.
Okay. So here is question number 6. This is objective type question, and it is asked, what is the minimum pressure differential that must be maintained between pollutants generating spaces and surrounding areas to control chemical pollutant transfer. It is talking about the smoking zone. Example of the smoking zone was given to you. So that negative pressure was discussed, I think. What negative pressure should be maintained? And it is not talking about the closed rooms. I want to state it clearly. It is not talking about the closed smoking rooms or something. It's just asking about how much pressure, negative pressure, or how much differential pressure should be maintained. So A, B, mix of answers again. So option B is the right answer for this question. That is, the minimum differential pressure of 5 pascals should be maintained between the pollutant generating species and surrounding areas to prevent the transfer of hazardous chemicals to the habitable areas. And when we are talking about the closed room, then it was mentioned as a 1 pascal. If you are able to recall, then if we are talking about the closed room, then at least it was mentioned. But the 5 pascal we have to mention, or you have to consider as the right answer for uh, eliminating this chemical pollutant or controlling this chemical pollutant transfer. So option B is the right answer, not A. Is it clear?
Yes, sir.
So whoever have answered A, they can refer to the slide of lecture this week for week 9, but lecture number 43. So there two quantities have been mentioned. 1 Pascal as well as 5 Pascal is also mentioned, but we are not talking about particularly for closed rooms. That is statement is also written. So if you are talking about in general, the minimum pressure difference should be 5 Pascal. Fine.
Yes, sir.
Okay. So here's the seventh question. In openable plan offices, all occupants have same experience of thermal comfort if cooling system is properly designed. Okay, so this is very clear to all of you, and this was not tricky question also. So all of you have answered it false, and you have answered it correctly. So although all the occupants will have experienced the same thermal comfort if the system is designed. So this is not correct answer or correct statement. The correct answer is false, as all of you have mentioned, because this thermal comfort level study, this is highly subjective quantity, or this is or you can say highly objective based study. So different occupants, they will be having different comfort range of comfort temperature, humidity, comfort levels. So if you are maintaining the same level of cooling, or you are designing it for same, so it is not likely to all the occupants that they will be facing the same thermal comfort. You like in a survey it was also asked, so whenever we are opening the or whenever 3 to 4 people are staying in an office or in an this flat. So if somebody wants to maintain the temperature to be in the range of 21, somebody wants to make it bit cooler around 19, someone wants to make it 24. So every person, this thermal comfort level, it is uh, varying. So that's why it is not obvious that always they will be experiencing the same comfort level. Fine.
Yes, sir.
Okay. So here is the eighth question. Which of the following is not considered as a composite wood or agri fiber product? So this is very straightforward question. Okay, and all of you have given it correctly. All of you have given the answers correctly. So still is the right answer for this one. Apart from that, the composite wood and agri fire products. This includes all the options, whether it will be particle board, or it will be plywood, white or wheat board, or straw board, panel substrate, or door coats, which are made from wood fibers or agricultural byproducts. But the steel is a metal, as you can identify it very well, and does not fall in this category, making it the correct answer for this question. Fine.
Yes, sir.
Okay. So here is the next question. Question number 9. What does the acronym MERV stands in context of indoor air quality and ventilation systems? Try to read all the 4 options and then answer to this question. What does MERV stands for? You can see in the slides, lecture slides, there also short form of this MERV acronym have been utilized. So what do you understand by this value? Let me see how many of you can answer it correctly. Before moving to the values or before moving to the next phase, let me see or let me understand how far you are attached with the basics. If you are not knowing the basic definition of this MERV term, then how can you can relate it with the values? What does it speaks? So let me see how many of you answered it correctly. D. Fine. So I think most of you have answered it correctly. D is the right answer for this question. That minimum efficiency reporting value, which is a rating system used to evaluate the efficiency of air filters in capturing particulate or particles of different sizes. And let's move to the last question of this lecture series. Here is the last question, question number 10. Is it visible?
Yes.
Okay, so answer to this question also, question number 10. Likewise, you have given to the answer to the previous questions. I hope this question also you will be answering it correctly. And I wanted to add one more thing I have announced in the initially also. Like in the next class, we will be focusing some of the numerical questions, and some part will be dedicated to the previous year questions and all. But in the rest of the part, we will be doing some simulation study, or we will be practicing or doing hands-on experience of the softwares, and which softwares are beneficial for this building performance evaluation and efficiency. That will be discussed with you in the lecture videos of week 10, and how to use that one, or this sort of case studies we will be doing with live sessions. So be ready with the next session, and I hope this will that session will be beneficial for you in your future also. So that thing we will be doing next session. So meanwhile, try to answer to this question number 10. Okay, so most of you are preferring to the option C for this particular question, question number 10, and C is the right answer for this question. So this is primarily done in order to improve the productivity of the people or comfort level or well-being of the occupants. The primary intent of the individual lighting control is to allow the occupants to adjust the lighting according to their specific needs and preferences, and this personalization is aimed at enhancing the productivity, as it is stated in option C, comfort, and making it easier for the individuals to focus on tasks effectively while reducing the energy consumption. That's why the option A, to reduce the overall energy consumption of the building, would have been answered, but it is on the secondary benefit. The primary benefit, as it is stated in the option C, whenever you will be achieving the option C or the primary benefit of this, then overall it will be reducing. That will be the secondary benefit or overall the result of the primary benefit. Fine. So option C is the right answer. Is it clear? Everybody is fine with option C?
Yes, so it's clear.
Yeah. So let's move to the lecture 44, indoor environment quality, part 4, some of the simple questions. Similarly, we will be doing the series of 10 sample questions for these lectures also, based on these lecture videos also. So here's the first question. Which standard is commonly used in designing thermal comfort in buildings? So when you're talking about the thermal comfort, so which standard you will be following? All of you, Elena has answered, Kyle has also answered. Others also try to give your opinion and based on your understanding of lecture 44, try to answer. Whether it will be NBC or SF 65 or 55 or ISO 7730. So again it is, so C is the right answer for this question. Whoever have answered B, for them I want to state, whenever you will be referring to the slide, first slide, because this is the first question, so you can refer to the beginning of the slide, open the lecture 44, and you can refer to the beginning of the lecture slides, whether it will be second slide or third slide. It is well mentioned that the SRF standard 55 is commonly used as a benchmark design for designing thermal comfort in building interiors. It is specifies the required thermal conditions for human occupancy, and that is globally accepted as standard. So option C is the right answer. SRF 55. Whoever have answered A, I think, apart from this C, they are now clear.
Yes, sir.
Okay. So here is question number second. Then try to give answer to this question number second also. Again, Elena is the first. She is very active in this problem solving session. Pile is also going with option D. What about others? What about Harshita, Tarun? Asha, Tarun also mentioned. Okay, fine. So from this you can easily see all the above is the right answer for this question. All these three parameters whichever is mentioned, temperature, humidity, air speed, these all environmental parameters must be considered, or they all are equally important in designing a thermally comfortable environment. Can we move to the next question?
Yes, sir.
Okay. So here's question number 3 for all of you. You have to identify which of the following is not considered as a personal parameter for thermal comfort design. This is not a personal parameter for thermal comfort design. You see, so Tarun is saying D, C, C. Okay, fine. So all of you are right. C is the right answer for this, or else other options like clothing insulation or metabolic rate or whatever activity you are involved in. All these will be the personal parameter and will be varying with person to person. But this option C, you can eliminate it from the personal parameter for thermal comfort design. And let's move to the next question. Question number 4. What is the intent of incorporating daylight in building design? Or what is the focus? Or what is the aim, you can say? So with this answer, I think this is also a very straightforward question, and all of you must be able to answer it correctly. Let me see. D, D, D. So D is the right answer for this one. So whenever you will be incorporating this daylight in the building design, so you will be focusing on all these primary objectives in order to reduce the need for artificial lighting, or to reduce the energy demand, or to improve the occupants productivity and visual comfort. So option D, all of you have chosen it correctly. Let's move to the next question. Question number 5. What is the recommended range for useful daylight illuminance, UDI we usually call it as, on work plan in a building design? Can anybody speak? What is the right answer?
C. Without
Pardon?
option C, sir.
Yeah. So option C is the right answer for this question. That is 100 to 2000 lux. This UDI value is the annual occurrence of the daylight. on the work plan, and the range is considered optimal for providing glare-free natural lighting while eliminating the need for artificial lighting as well. Fine. Let's move to the next question. Question number 6. What is the angle of obstruction, or what do you understand by angle of obstruction in context of green building design? Fine. So these all the options are bit tricky, but I hope you will be choosing the final and the most appropriate answer out of the four. Angle of obstructions, when you are designing windows or setting overhangs, then in context of that or green buildings design you can answer it correctly. Let me see how many of you were answered correctly. So C, 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 D. Initially everybody was moving towards C. Now Tarun is moving towards D. Only fine. So option C is the right answer for this angle of obstruction. That is the angle formed by the window center within the nearest obstruction. The angle of obstruction refers to the angle formed between the center of a window and the maximum height of the nearest obstruction. This is crucial for determining the amount of daylight and the outdoor view that the window can offer. That's why option C is the right answer, and most of you have answered it correctly. I think now it is clear. Can we move to the question number 7? Fine.
Yes, sir.
Okay. Here is question number 7. What is the following factors, or which of the following factors should be balanced when selecting the glass for windows to control the heat as well as the daylight simultaneously? Solar heat gain coefficient, U value, solar heat gain coefficient, visual light transmittance, and U value, and none of the above. I think discussion of this one we have already done in some of the problem solving session. So in order, if you will be allowing more light or heat to enter, then it will be also not good. So you have to maintain a balance between both of them, as well, light as well as heat. So which property you would be choosing or focusing on? B. Okay. So all of you have answered it, option B only, and B is the right answer. While selecting the glass for windows, there should be a balance between solar heat gain coefficient, which is called as HHGC, and the visual light transmittance, which is referred as VLT. Both of them ensures that the reduce heat gains as well as enough daylight penetrates in the interior of the building. Fine. Let's move to the next question. Question number 8. Here is question number 8. If the external illuminance outside a building is 5000 lux, this is a numerical type of questions, and this example was given in the lecture slides as well as in the assignment. One of the questions similar to this was asked. So I hope if you have gone through the lecture slides and you have solved the assignment questions, then you will be able to answer to this question also. Just you have to apply the formula for the external illuminance and calculate it, then mark the correct answer in the chat box, or you can speak it what will be the right answer out of the four options.
On
How much?
option 100.
Voice is breaking. B. So most of you have answered option B, and B is the right answer. 100 lux. Fine. So this is directly picked up from the lecture slide example question. So that thing conversion of this one you can refer to that there was a simple relationship between this daylight factor and the illuminance that you can utilize for evaluating the correct answer, that is 100 lakhs. Here is the ninth question from lecture 44 based on the lecture 44 of week 9. Daylight factor is the ratio of daylight or light levels inside a structure to the light level outside, expressed as a percentage. So this is true or false? So try to recall the definition of this DF, daylight factor, and then answer to this question. Two of you are saying true. Rest also try to give answer. So this statement is absolutely true. The daylight factor is accounted as a ratio of indoor illuminance to the outdoor illuminance, and it is expressed as a percentage that helps in determining how much natural light is available inside a building compared to the outside. So this is true, and I let me see all of you have answered it correctly or not. Okay, so all of you have answered it correctly. Fine. Let's move to the next question. Last question of lecture 44. Here's the question 10. Which of the following is not a component of daylight considered in the calculation of indoor illuminance? So try to answer to this question also, whether this is sky component or externally reflected component, internally reflected component, or solar radiant coefficient. Which of the following you don't consider while calculating the daylight in the calculation of indoor illuminance? Let me see.
It's
Okay, so all of you are saying option D only. Option D is the right answer. Solar Hilgen coefficient and the other components, whichever is mentioned in option A, B, C, that is the components of sky or externally reflected component or internally reflected components. All these components of indoor illuminance in daylight calculations are considered, and the last option it is not considered, but it relates the heat ingresses. When you will be calculating the heat transfer, then this component you will be considering, but when you are calculating the illness, then this becomes less important or insignificant in term in compared to the other two options. Fine. So let's move to the last phase of the sample problems, where we will be solving the 10 questions similarly from the lecture 45 indoor environment quality part 5. So here is the first question. Try to answer to this question. Eco certified products are always ergonomically designed. Is it true or false? So as I can see, most of you are saying it as a false. Yeah, fine. So I want to first of all disclose the answer. That is for this question, false is the right answer. So whoever have answered true, so I think they are lacking some sort of mm, some sort of correct concept related to this. So whoever have answered it correctly, that is false. Can you tell me why this statement is false, so that others can understand? Who have answered it correctly? Let me see. So Payal and Tarun, they have answered it correctly. So can you explain me why you have answered it correctly or why it is false? Payal, are you there?
Not be
yes, sir.
Yeah. So can you explain others why you have mentioned it false?
certified
That's are related
Yeah, I think some echo is
are
there.
in environmental impact.
Okay, so when
Ergonomically,
hmm, I think your voice is not
products are always ergonomically.
your voice is not clear to me. Let me explain. These eco-certified products are designed with sustainability in mind. That is for sure. Focusing on environmental impacts and materials. It does not guarantee that they are agronomically designed. So the statement that is written, these eco-certified products are always agronomically designed. This is false. These eco-certified products are designed with sustainability in mind, focusing on environment and materials. This does not guarantee that they are always agronomically designed. Fine.
Yes, sir.
Okay.
Yes, sir.
So here is the second question. Then, according to the compliance approach, how much of the carpet area should be allocated to circulation spaces in interior designs? 10%, 25%, 30%, and 55%.
It's 25%.
It's 25%. So the correct answer is 25% only. The compliance approach that mandates at least 25% of the carpet area in the building should be designed as circulation spaces to ensure the safety and well-being of the occupants. Fine, you are absolutely correct. Let's move to the third question. Which certifications are suggested for eco-certified interiors? For when you are doing the eco-certification of the interiors, then which of the following organization or this guideline provide you the certification out of the four options?
Option B, sir.
Yeah. So this time also you have answered it correctly. Option B is the right answer. It is BIFMA and Green Guard. Both of these certifications are important for the interior furniture to be eco certified. It should be sourced from the companies certified by the organizations that have been mentioned. Option B, that is BIFMA or Green Guard, ensuring the furniture meets the environmental sustainability standards. And let's move to the question number 4. Here is question number 4. Yeah, so this is the tricky questions. Let's see how many of you are able to choose the correct answer.
Option C.
Okay, let's wait others also. Chaturun is also saying C. Fine, fine. What about others? So Payal is mentioning B or C.
No, sir. I have given the answer for last question.
Okay,
This option C is right answer.
okay. So option C is the right answer for this question, to address the occupants' health and well-being. This agronomically designed furniture is necessary to prevent the health issues like back pain or shoulder problems or other posture related to the problems among the occupants who sit for long periods, ensuring their long-term health and comfort. That's why it is based on, or it is mainly designed to address the occupants' health and well-being. Option C, you have marked it correctly. So let's see how many of you can mark the correct answer to this question number 5 as well. Here's question number 5. Why it is important to incorporate indoor plants in the building interiors?
Correct. कैप्स लॉक चालू करने दो.
Pardon? Someone was saying something. B. So all of you have answered it correctly. Option B is the right answer for this question. That is, indoor plants are crucial for improving the health and well-being of the occupants by absorbing the toxins such as formaldehyde or carbon dioxide and creating a soothing and vibrant indoor environments. Fine. So everybody is fine with option B.
In, I
Yes,
think
sir.
in this case, except C, A, B, and D, all three are valid. Except they reduce energy consumption, otherwise all three are valid.
Yeah, yeah, you can opt it as a multiple choice question also. But if you will go, then overall the option B, it is the most
Overall,
suitable
it is
option because we are doing for aesthetic appeal. We can also put the show plants or these plastic plants, you can say, or some good other ornaments or other things that can give you a good aesthetic appeal in the building, but it cannot improve the
yes,
quality of air. Are you getting?
yes, sir.
Yeah. So aesthetic appeal is not the primary because aesthetic appeal can be provided by other good ornaments or designs or paintings as well. But it will be overall improving the quality of air. That's why plants are considered. Fine.
Yes,
Okay. Thanks
yes, sir.
for your discussion. So let's move to the question number 6. Here is question number 6. Which of the following certifications is used to ensure the cleaning agent is cleaning agents used in interior spaces are environmentally friendly and safe for human health? So for these cleaning agents, which certifications you prefer or which certifications you refer, I should say. Out of the four options, BIFMA certification or Green Seal certification or ISO TC 159 certification or LEED certification. Let's see how many of you can answer to this question also. So C, B, two kind of answers again I'm getting. Although this question you can refer, I can also tell you the slide. You can refer to the slide which was discussed, which is showing 16 real time. When it was discussed nearly about 16 minutes, or you can watch the video and you can pause or start from the 16-minute duration. At that time, it was discussed by the professor that which certification is better.
Sir, it's B, Green Seal certification.
Yeah, green seal certification B is the right answer for this question, which is one of the certification ensuring that cleaning agents and consumable used in the buildings are environmentally friendly and safe for the human health. So you will have to mark B for this question number 6. Let's move to the seventh question. Here is the question number 7. What percentage of the regularly occupied areas in a building must have direct outdoor views as per indoor environment quality standards?
It's D, 40%.
So I must say that Payal is very confident with her answer and all the answers she is giving correctly. But apart from her, I would also like others also to answer to this question number 7 and give their active participation and how far they understand the question and these lecture videos. It will be tested, or this is also kind of quick revision. So try to answer to these questions like Payal is doing. She is absolutely participating or actively participating to this session and keeping her point of view is and doubt. I expect the same kind of thing from everyone. So what will be the right answer for this question number 7? What will be the right answer?
D, sir, 40%.
Yeah. So 40% is the right answer. At least 40% of the all regularly occupied spaces in a building must have access to the direct outdoor views through vision glazing to enhance the occupant well-being. Fine. So let's move to the question number 8. Here is question number 8. Similarly, you try to answer what percentage of the building occupants at least have access to recreational facilities such as gyms or yoga spaces in large office.
5%.
5%. 5% is the right answer for these questions. And Tarun, Payal all have also already answered in the chat box as well. So 5% is the right answer. It is been discussed with you that the recreational facilities should also be given importance and should be provided at least 5% area of the building so that the occupants in large offices can get or if the promotion of well-being and reduce the heat stresses associated with the long working hours can be avoided. Fine. Here is the next question. Question number 9. India currently has its own certification system for green consumable use in the building interiors. Whether this is true or false. So this was also discussed in the last video during 16 after 16 minutes. So you can watch the videos 16 to 17 minutes interval. You can see how ma'am has very well discussed about this one. So whether India has its own certification for green consumables or not. Let me see how many of you can answer. False, false. So everybody is fine with answer false?
Yes, sir.
Yeah. Uh, False is the right answer for this question. Currently, India has or India does not have a specific certification system for green consumables. However, there are many organic products available that can serve as a eco-friendly alternatives for cleaning and daily maintenance. That was stated by man. Fine. So let's move to the last question or last sample paper problem of this week 9. And here is the last question. What does the acronym NRC stands in concept of building acoustics? I hope you will be able to answer to this question correctly and you have heard to this term B. So everybody is opting for the option B, noise reduction coefficient, and option B is the right answer. What can anybody tell me what is the range of NRC? What values or what is the range of NRC coefficient? Noise reduction coefficient. What is the range of that value? Anybody can speak and
35 to 40 decibels.
no, it is coefficient.
Point 3 to point 0.7.
Fine. Can anybody wants to add to this answer? What range it can take? Noise reduction coefficient. If it is reducing whole noise, and if it is not able to reduce do the reduction of the noise or echo, so it can vary in some sort of range. Then you will be allotting some values for this particular building or particular wall. So what will be the higher and lower range value of this noise reduction coefficient?
Sir, it depends on like the structure. According to the video, we have like 0.3 greater than
That is
0.34
fine.
floors.
That is fine. What I'm saying what maximum value and what minimum value it can take. That is called as range of values.
No idea, sir.
Fine. Can anybody tell what maximum and minimum value of this NRC can be accommodated or can fall? So if a material is absorbing all the sound, So how much NRC value it will be having? Noise reduction of that material will be how much? 0 or 1?
1.
Yeah. Similarly, if it is not able to absorb the sound, then the noise reduction value of that material will be 0. So it is falling, you can observe whatever examples ma'am have given, it is falling in the range of 0 to 1. It cannot go beyond 1 and it cannot go beyond 0. Okay? It cannot be minus. So this is the significance of that value, you can say. So it is falling in the range of 0 to 1 for all the materials whichever you will pick. All the noise reduction coefficient values are given in the range of 0 to 1. Am I clear?
Yes, sir.
Yes, sir.
Yeah, that thing I was asking. I was not asking about one particular floor or this wall. Fine. With this, I would like to thank you, all of you, for participating in these sample problem questions. But before ending to the class, I would like to discuss upon the previous year questions. So I hope there are just 10 questions, and most of them we have covered in our sample problem and the assignment questions of week 9 also. So we will be just discussing these 10 last 10 questions of previous year, and I hope all of you will be able to answer to these questions correctly, and 100% answers I will be accepting it. So let's move to the previous year questions. Here is the first question. So what should be the right answer based on our all the discussion that we
PPM.
have done?
Option C.
It's
Option C. Fine. 1000 ppm is the permissible limit or maximum CO2 concentration allowed in the buildings. Correct. Let's see how many of you can answer to this question second correctly.
option A.
Option C.
Option A. Fine. So this was directly asked in your previous year question. So this thing you should be knowing. Fine. Let's see how many of you can answer the third question also based on the time that you have given to this problem solving session. How far you have understood your and revised your concepts. Then you can be able to answer to this third question also.
Number of occupants.
Option B.
Fine. Everybody is clear?
Yes, sir.
Okay.
Yes, sir.
So similarly, try to give the correct answer to option this question number 4 as well. So I have talked about the principle of mechanical
D.
ventilation.
It's D, sir.
Yeah.
D. D.
B or D?
D. Ensuring
D.
minimum daylight.
Yeah.
Ensure minimum daylight.
So D is the right answer. Mechanical ventilation that focuses on the air quality, climate control, but not on the daylight. That's why option D gets eliminated. Fine. So till now you have given all the answers correctly. Let's move to the fifth question and see whether you will be able to solve the fifth question also if it will be asked in the exam or not. Here is the fifth question.
Nitrogen oxide.
Option C, nitrogen oxide.
Yeah. So this was also discussed in the lecture videos as well as in the sample problems. So you should be able to answer to this question now. It is nitrogen oxide. Fine. So let's see how many of you can answer to the sixth question correctly. Here is the sixth question.
True.
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 True, sir.
Yeah. The this statement is right. The underfloor air distribution system allows for customized temperature and airflow control, enhancing the occupant comfort by providing individualized condition. Fine. So till sixth question, all of you have answered it correctly. I don't think anybody have answered wrongly. So let's see last four questions also, and I hope all of you will be able to answer the last four questions also correctly. Here is the seventh question.
Daylight factor.
Option B.
It's a daylight fixture.
Yeah. So this was also asked directly in the previous year question. So definition of this daylight factor should also be clear to all of you. Then you will be able to answer to this question. And all of you have given the right answer only. That option B is the right answer for this question. So let's move to the eighth question. Here is the eighth question.
Useful daylight illuminance.
D.
Option D, UDI.
UDI. Correct?
Yes, sir.
Yes, sir.
Okay. Daylight. So option is D is not the right answer. So when I was solving for the sample problems, this lux value I was in the work plane I have discussed. This was discussed for daylight factor. The what you people have mentioned. Let me open that one again. So this just now we have discussed when you were mentioning it is from 100 to 2000 lux. Okay.
Sir, as per slide, is related to UDI only.
Yeah, yeah. It is UDI. Fine. That we have discussed in this sample problem 5 only. Isn't it?
Yes, sir.
Yeah. So it will
Yes, sir.
be UDI. Yeah, and it is written in which slide? Slide number?
So let me check.
Yeah. You can check it and or inform the slide number and lecture number to others also.
Lecture number is 44.
Yeah, it will be in 44. Absolutely right. So you can check the slide number also and inform to the others. They can refer. You are able to check or should I open?
Sir, just a minute.
Yeah.
Sixth slide. Lecture 44, sixth slide.
Yeah. Lecture 44, 6 slide. So it is UDI. Fine. So for question number 7, it was daylight factor. Here's question number 7. For this one, the correct answer was daylight factor. But for question number 8, as you can refer to the slide 6 of lecture 44, it is UDI. Fine. So all of you have answered it correctly. Let's move to the ninth question.
Sir, it's slide 15.
Okay. So you can refer to the all the slides. There's I think not more than 15 to 20 slides. You can easily see the numbers. Can we move to the next question?
Yes, sir.
So here is the ninth question. This
Furniture.
this thing we have discussed just now.
Furnitures.
Yes, sir.
So what will be the full form? Can anybody tell? This thing can also be
No,
asked.
sir, I don't know.
Anybody knows? It is Business
Yes.
and Institutional Furniture Manufacturer Association, BIFMM. You can search it later also, so you should be knowing. Fine.
Okay, sir.
Okay. So here is the 10th question and the last question of previous year. How do plants in the office indoor plant in helping you? This was also discussed. So I hope this now you can answer it correctly.
Option A, sir.
Observed toxins like formaldehyde.
Yeah, option A is the right answer. These indoor plants can improve the air quality by absorbing the harmful substance like formaldehyde, as I was saying, and some of the VOC compounds, and also reducing the CO2 levels and contributing to the healthier working environment. Fine. So with this week 9 problem solving session comes to an end, and I hope all of you have enjoyed it, and we will be meeting you all in the next problem solving session on next Tuesday, where we will be solving the sample problems as well as we will be doing the previous year questions practice. And apart from that, one more section we will be giving or dedicating some time to our hands-on experience of the simulation softwares that is on demand nowadays for building energy performance analysis. We will be doing the discussion and some worked on exam handouts and some examples on that. So meet you all of you in the next session. Fine.
Yes, sir.
Thank you all
Okay.
Thank
of
you,
you.
sir.
Thank
Okay, sir.
thank you.
Thank you, sir.